Okay, we continue curve sketching, and Jake already started by looking at the problem. He said that the limit was 2. How do you know that, Jake? Jake is correct. The limit as x goes to infinity, positive or negative infinity, of the function is equal to 2. Now, if you needed to work that out by factoring x squared out of the top and an x squared out of the bottom, you could go ahead and do so. If on the test I ask you to show the limit algebraically, then you need to do that. But if I just ask for a vertical asymptote or horizontal, or if I ask for a horizontal asymptote and behavior, you just say 2. If you recognize it, go ahead. Everybody good with that? So for this type of problem, I don't expect that you would show your work. But if I give a problem and I say, find the limit as x goes to infinity of that thing, okay, and show your work algebraically, I don't just want one answer. I don't just want you to write down the answer. I want you to show some work in the process. Okay, very good. All right, where do you want to move now? So I got a horizontal asymptote of y equals 2. That's end behavior and horizontal asymptote in this case go together, okay? It's a rational function. Leah? So when the end behavior comes out to be a constant like this, that means you got a horizontal asymptote. Okay? Vertical asymptote. Plus or minus 1. Very good. I look at where the denominator is undefined. Denominators are where the denominator is 0, and so the whole function is undefined at 1 and negative 1. Everybody got that? So the vertical asymptotes, I'm going to look at the denominator where the function is undefined. That's going to be at 1 and negative 1 is x squared minus 1 factors. Everybody good? All right. Y-intercept is super easy to find. I plug in 0 for x. I plug in 0 for x, and I get 0. Very good. If I want to find the x-intercept, I set the function equal to 0. When I set the function equal to 0, do I look for where the top is equal to 0 or where the bottom is equal to 0? Top. Where does top equal to 0? 0. So it passes through the origin. All right. All the rest of the information I gather from taking first and second derivatives and going through the tests. Here's what some people are getting confused with the other hour. Increasing and decreasing. Those first derivative or second derivative? Concave up, concave down. Local min and local max. Inflection. Okay, so you got to know which derivative test gives you which result. So let's take the first derivative. What rule do I use? I showed the other class how to do the problem a little bit differently, but nobody liked it, so I'm not going to do that. I would actually divide this through, but whatever. So we'll just do this, okay? Derivative of the top. 4x times the bottom, x squared minus 1, minus the top, which is 2x squared times the bottom derivative, which is 2x, right? All over x squared minus 1 quantity squared. What's going to happen? So, Michael, if there was an x squared minus 1 over here, you could take an x squared minus 1 out of each term. Yeah, but you got a 4x cubed and a negative 4x cubed, so those are going to cancel, right? So you just get a negative 4x in the numerator. Thank you, Maddie. Sweet. Do you know what that looks like? But the bottom is always positive, isn't it? So we know the bottom is always positive. We got put our points. We got 0. We got negative 1. We got positive 1. Where did I get those? Okay, those are critical points and where it's undefined. So it's undefined at negative 1 and positive 1. Critical point exists at 0. So I know the bottom is always positive. If I plug in a negative, what am I going to get at the top? So I'll have positive. Negative, we'll get a positive. If I plug in a positive, we get a negative. Carter, you see that? Okay, thought you had a question. All right. Because I know the bottom's always positive because it's squared, right? So I don't have to worry about really plugging in the bottom. I could, it'd just be wasting time. Good? Okay. So, what does that tell me? What have I learned? What information have I gleaned? What can I answer? Okay, where is the local max? At 0. I plug 0 back in and you get 0. That was super easy. Original. There is no local min. Increasing. So -1. Union with -1 is 0. So a lot of people go from negative infinity to 0. We can't include -1 because -1 is not part of the domain. Decreasing. Awesome. My first derivative test is used up. I want more information. I'm going to take a second derivative. Are you scared? Terrified. Petrified. Stupefied. Have you ever seen Beautiful Mind? No. Russell Crowe. All right. Derivative at the top. If you brought x squared minus 1 quantity squared to the numerator, you would then use the chain rule, but you would have to use it in cooperation with the product rule. So I don't know if that really makes it any easier for us. Derivative at the top is -4 times x squared minus 1 quantity squared. Minus the top, right? So plus 4x times the derivative of the bottom. Yep, better use that chain rule. Good thing we got that, huh? Yeah, I got a 4x there. And what's u? X squared minus 1 all over the bottom, the fourth. Michael, what can I take out? Nice job. Let's take out that x squared minus 1 because it's each term has one. When I say term, separated by addition. So this term has an x squared minus 1, this term has an x squared minus 1, and there's one in the denominator. So I can remove one from each. It would be just like factoring it out and dividing it off. Gone, reduces to 1, reduces to 3. So f double prime of x, we're almost there. Negative 4x squared and positive 16x squared makes 12x squared plus 4 all over x squared minus 1 cubed. So I've got -4 times x squared is -4x squared. I got 4x times 4x is 16x squared. Got it? Okay. Where is the top equal to 0? Never is. Why, Carter? Why is it always positive? Squared and? Sure. Yeah. So everything's positive up there and it's being squared. If you think about the graph sits above the x-axis the entire time, right? 12x squared plus 4 is above the x-axis the entire time. So that's a good deal. We know it never crosses 0, so the top is always positive. So we don't really need to focus on the top at all, do we? Is the bottom always positive? No, it's not. What points do we use? What points do we test? Or yeah, 1 and -1, because that's where it's undefined. So I'm just going to consider the denominator then in order to determine where I'm positive and negative. What number would you like to plug in? Negative 2 squared is 4. Minus 1 is 3. Cubed, positive. We want to plug it now. All right, it's from f double prime, which happens to be also in f prime, which happens to also be in the original function, right? If it's in the original, if it's undefined for the original, it's going to pop up in the derivatives as well. Because this is never equal to 0. Okay, I plug in 0 and I get 0 minus 1 is negative 1. Cubed is negative. Plug in positive 2, I get a positive. What does that tell me? Very good. Local max. No. Okay, good try. That, which test is that? F prime, but we got F double prime going on. F double prime doesn't tell us about local min or local max so much as it does concavity. Concave up from negative infinity to negative 1. Here is 1 to infinity. Concave down in between. Hey, buddy. Inflection. Negative 1 and 1. Awesome. We got to plug them back in and get our points, right? Yeah, it doesn't work, does it? So can we include them in as inflection points? No. So I let us kind of go down that road. I want you to understand, you see it change inflection, or you see it change concavity. So you're like, okay, I want to include those. But remember, these are not part of our original domain. So does the graph change concavity? Yes. But is there a point in the domain at which it changes concavity? No. So it doesn't have an inflection point. See what I'm saying? Okay. All right. So you plug in 1. Hey, what's up? I don't have many left. I know Miss Tran does. Pop, if she doesn't, she should have 8. If she doesn't, come back and see me. Okay? All right. So let's make your point, Kelvin. You said looks like it's got an inflection point at 1, right? For crying out loud, it changes from negative to positive. Agreed? So then go ahead and plug that 1 back in the original, and you get 2 over 0. I got nothing. Does that make sense? Okay, so you don't have an inflection point. Last thing to do is graph it. Now, just pause to take it in. Do you have any idea what this stick graph looks like when you just look at it from the beginning? Okay, Chicos is smarter than everybody else, okay? But for those of us that aren't so smart, okay, I don't know what it looks like, okay? Let's figure it out. Well, I did do it in second hour, but it's fun to do it again. Let's do like a 6x6 graph, okay? Fine, Jake, do whatever you want. Who was it? B Road? For graduation, I'm gonna buy you a shirt. It's gonna say, gets his little buddy. All right, here we go. What do I plot? What do you want, Mark? Okay, you want to do 0, 0 on asymptotes. Let's do it. So I got 0, 0 right there. And I'll do some asymptotes. I've got a negative 1. I got positive 1. What's my other asymptote? Y equals 2. Now think about the asymptote shows end behavior, right? So the horizontal one. So that doesn't mean that it's necessarily going to have anything to do with the middle. That means it's going to have kind of, direction at the end. Who knows? That's a good question. We'll have to kind of look at our information and decide what it tells us to do. So let's look at this section here. From negative infinity to negative 1. What do I know about the graph from negative infinity to negative 1? It's increasing and it's concave up. So which one's it going to be in, the top or bottom? Top. Okay, so I'm going to cross these off just so I know I already talked about them. Okay, those are done. What about from 1 to infinity? It's decreasing and so is it going to be in the top or bottom? If it's decreasing and concave up. Top. Decreasing, concave up. So I took care of that part. And now, what about between negative 1 and 1? It's concave down, and it goes from increasing to decreasing. So it goes from increasing to decreasing, and it's concave down. Huh. Okay. You're a liar. Are you ready? It's the big reveal. Well, that's because my calculator is stupid. So the TI-83 is too dumb. Like Jill's got TI-84. Hers won't put the asymptotes on there. Mine can't handle it. It's all about the pixels. Okay, so there you go. It's kind of cool. That's it, folks. Go get some brain food. Come back smarter. You got the rest of the time to work.